Hello and good morning dear students. So in today's class we'll start a new topic which is multiplication theorem on probability. Okay, so multiplication theorem on probability. This is the topic for today. But before that, let us go back to our conditional probability. Okay, we know our conditional probability A slash B is given by probability A intersection B divided by probability of B, and probability B slash A is equals to probability of B intersection A divided by probability of A. So these two formulas we have done in the previous exercise 10.2, which was conditional probability. Now in order to get the formula of multiplication theorem on probability, what we'll do is from this we'll find the value for probability of A intersection B by cross multiplication, which will be probability of B slash A into probability of B. So probability of A intersection B is equals to probability A slash B into probability of B. Keep it as equation number 1. Similarly, from here also we know B intersection A is same as A intersection B. So if you cross multiply, you'll get the value for this, which is this. Alright, so equation number 1 and equation number 2. So look at this, both of the equation, you'll find the value for probability of A intersection B as this and probability of A intersection B as this. So if I combine equation number 1 and equation number 2, then the value for probability of A intersection B will be probability of A slash B into probability of B, which is equals to probability of B slash A is into probability of A. So this leads to us multiplication theorem on probability, provided probability of A not equals to 0 and probability of B should also be not is equals to 0. So very simple formula, multiplication theorem on probability. Once again, the formula is probability of A intersection B is equals to probability of A slash B into probability of B, which is equals to, it's very easy to remember, A slash B into probability of B and B slash A into probability of A. Very, very simple and easy. Okay, so pause the video and note it down. Alright, let's proceed now. The next topic which we'll learn in this exercise is independent events. What events? Independent events. Okay, now A and B are said to be two independent events. A and B are said to be, you can also write down, A and B are said to be, okay? A and B, two events, okay, you can write down two events. A and B are said to be independent events if the occurrence of A or non-occurrence of A does not affect the other one, which is B. Okay, so both should be different. Occurrence of A does not affect the occurrence of B. Are you understanding my point? Suppose I roll a die, then the chances of getting 1 is 1 by 6, and then the chances of getting 3 is also 1 by 6. So it does not affect 1 and 3, right? Okay, so similar to that, two events A and B are said to be independent events if the occurrence or non-occurrence of any of the event does not affect the other one. Okay, to understand it more clearly, now mathematically, in terms of probability, how will I check whether A and B are independent events or not, is by using these two formulas. Alright, if A and B are independent events, please note it down. If A and B are said to be independent events, then probability of A intersection B will always be is equals to probability of A into probability of B. Okay, to be independent. Okay, to be independent, if A and B are said to be independent events, then probability of A intersection B will always be equals to probability of A into probability of B, if it is independent. If it is not independent, then probability of A intersection B is not equals to probability of A into probability of B. This is the formula, please note it down. And also, if A and B are independent events, then probability of A slash B is always equals to probability of A, and probability of B slash A is also equals to probability of B, provided probability of A and B are both non-zero. Okay, so pause the video, note it down. Along with this, you will also go through the the examples out here. Go through the examples in page number A1015. A1015, please go through the examples and also read about independent events. Then it will be more clear to you. Alright? And now we start our exercise. So pause the video, note it down. Alright, let's start with exercise 10.3. Exercise 10.3, and we are doing exercise on multiplication theorem of probability and independent events. Alright, so the first few questions are based on independent events, and then we'll move on to multiplication theorem of probability. Okay, once again, let's go to independent events. Two events A and B are said to be independent to each other if probability of A intersection B is equals to probability of A into probability of B. Please note down the formula. Okay, now the question given to us out here is, if A and B are two events with probability of A equals to 1 by 2 and with probability of B equals to 7 by 12 and probability not A or not B is equals to 1 by 4, then we are to check whether A and B are independent or not. So these are the things given to us, and we have to check whether A and B are independent or not. So if they are independent, then this relation must satisfy. Okay, now come back out here. A given, B given. We'll start with this. Probability A naught or not B. So which means probability A complement union B complement is equals to 1 by 4. Now use the De Morgan's law. A complement union B complement means A intersection B whole complement. This was the De Morgan's law. And we know that probability of A intersection B whole complement is always equals to 1 minus probability of A intersection B complement, A intersection B. And from here easily I can find the value for probability of A intersection B, which is 1 minus 1 by 4, which is 4 minus 1, 3 by 4. So 3 by 4 is the value for probability A intersection B. Now, remember that we are checking independent or not. So I have probability of A into probability of B, which is 1 by 2 into 7 by 12, and which is no way equals to 3 by 4 because this is 7 by 24. So as probability of A intersection B not is equals to probability of A into B, therefore what does it imply? It implies that A and B are not independent events. Am I clear with this, everyone? Very simple and very easy. If these two events are independent, then both of them has to be equal. Okay, so pause the video, note it down. Alright, let's proceed with another question. Number 4, given to us probability of A equals to 3 by 5, probability of B equals to 1 by 5, and we need to find probability of A intersection B. Also given that A and B are independent events. Now A and B are independent events given to us. So if A and B are independent events, then probability of A intersection B is directly equals to probability of A into probability of B. Okay, because A and B are independent events. Put their values respectively, 3 by 5 into 1 by 5, which will be 3 by 25, which is the value for probability of A intersection B. A straightforward question. Pause the video, note it down. Alright, let's proceed with question number 4 part 2. Question number 4 part 2, given to us A and B are independent events. Already given to us A and B are independent events with probability B complement 0.65 and probability A union B 0.85. We need to find the value for probability of A. Okay, so step by step I'm going to explain you. Please focus on the board. A and B are independent events, which means probability of A intersection B is equals to probability of A into probability of B. This is the meaning of independent events. A and B are independent events means probability of A intersection B is probability of A into probability of B. Okay. Another thing is given to us is probability of B complement is 0.65 and union is 0.85. Okay. So let's start with B complement. Now if B complement is 0.65, then I can easily find probability of B. Use this formula, 1 minus probability of B is equals to 0.65 in place of this. And take this side, bring this side, 1 minus 0.65 is 0.35. So it is not a big problem. Easily we can find the value for probability of B. I hope you're clear till here. Great. Okay, let's move ahead. Union is 0.85. Probability of A union B is 0.85. Do we know the formula for union? Obviously yes. Probability of A plus probability of B minus probability of A intersection B. In place of A union B, I can use this formula, which is equals to 0.85. Okay. Now already I know A intersection B means A intersection B is equals to P of A into P of B, because these two events A and B are independent. So put the values. P of A, keep it as P of A. P of B 0.35. P of A, keep it as it is. P of B, also keep it as it is for now, is equals to 0.85. Okay, so what will you do? You'll take this 0.35 to the right hand side, sorry, left hand side, it becomes minus, and therefore P of A minus P of A into P of B is equals to 0.85 minus 0.35. Can you take P of A common? Obviously yes, take P of A common. 1 minus P of B is equals to 0. If you subtract, you'll get 50. Put the value for P of B, 0.35. So therefore, 1 minus 0.35 is 0.65. So hence the value for P of A will be 0.50 divided by 0.65. And now you can easily find the value for probability of A by cancellation. Okay, so pause the video and note it down. Alright, let's move ahead with question number 5, which will be the last sum for today. Alright, the question says a fair coin and an unbiased die is rolled. At the same time, you have a coin and you have a die, okay, and you are, rolling it together. So what kind of sample spaces will you get? See, a coin has head and tail, and a die has 1, 2, 3, 4, 5, 6, right? So therefore the sample space, first I'll take with head. I might get head comma 1, isn't it? I'm tossing a coin and I'm rolling a die. I might get head comma 1. I might also get head comma 2. Similarly, head comma 3, it goes up to head comma 6. I might also get tail comma 1, tail comma 2, and similarly it goes up to tail comma 6. So as a whole, total number of sample space, total outcomes will be 12 outcomes. I hope everyone is clear with this. Okay, let's read more. Capital A be the event, head appears on the coin, and capital B be the event, 3 appears on the die. Okay, according to the question, A is the event, head appears on the coin, and capital B, the event, 3 appears on the die. We are to check now, whether A and B are independent or not. So we are to check whether, right, probability of A intersection B is equals to probability of A into B or not, which means whether they are independent or not. Am I clear? Whether they are independent or not. Okay, since the events is given to us, so therefore what is A? What is my A? Head appears on the coin. So inside A I have H comma 1, H comma 2 goes up to H comma 6. Okay, A is the event, head appears on the coin. So which I'll take? Head comma 1, head comma only with H, right? So what will be probability of A? Probability of A will be 6 comma 12. Probability of A will be 6 comma 12. We can cancel it, which will be 1 by 2. Okay. Now I'll go to B. Okay, this is event A, this is event B. What is my event B? 3 appears on the die. 3 appears on the die. Remember that there is H comma 3, there is also T comma 3. So 3 appears on the die. There are only 2 cases, H comma 3, T comma 3. Okay? I do need to find probability. Oh yes, I need to find probability of B also. So probability of B is how much? How many favorable chances of getting 3 on the die? Only 2. So that is 2 by 12, which is 1 by 6. Okay, and the last one I need to find is intersection. Okay, which is the common elements in between intersection A and B? A intersection B. Alright, so A intersection B. Inside A intersection B, there is only one, that is H comma 3, because there is H comma 1, H comma 2, H comma 3 till H comma 6. B has H comma 3, T comma 3. Okay, so the common element is only H comma 3. So therefore, if I find the intersection, it will be 1 by 12. Alright, so let us now put these values in equation number 1. Okay, so from equation 1, you can write from equation 1, what is the value for A intersection B? Probability of A intersection B, 1 by 12, which equals to, what is the value for probability of A? Probability of A is also 1 by 2. And what is the value for probability of B? 1 by 6. So if you multiply, you'll be getting 1 by 12, which is equals to 1 by 12. So what does it imply? It implies that A and B are independent events. Am I clear? So we have checked that A and B are independent events because that formula is satisfied out here. So alright, we'll keep this much for today. Question number 6, a hint I've given out here. You can copy the hint and solve question number 6. Question number 7 and question number 8. Also you can do it very easily. All these questions are based on independent events. So that's it for today, and I'll see you tomorrow in the next one. Okay, take care and bye-bye.